this video, we will discuss about glucose, cyclic structure of glucose and anomers of glucose. First come to cyclic structure of glucose. In the previous video, we have discussed the open chain structure of glucose. Following reactions and effects could not be explained by the open chain structure of glucose. First one is, despite having the aldehyde group, glucose does not give Schiff's test and it does not form the hydrogen sulfide addition product with NaHSO3. Okay. Second one is, the pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. Third one is, glucose is found to exist in two different crystalline forms, which are named as alpha and beta. The alpha form of glucose with melting point 419 Kelvin is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, while the beta form with melting point 423 Kelvin is obtained by crystallization from hot and saturated aqua solution at 371 Kelvin. Okay. And that's why it was proposed that the OH group at C5 may add to the CHO group and form a cyclic hemiacetal structure. This explains the absence of CHO group and also existence of glucose in two forms, that is alpha form and beta form. Let us try to understand. We already discussed the open chain structure of glucose, and this can be written like this. Okay. This is first carbon atom and last carbon atom we indicated. Now, the four carbon atoms are represented like this. These intersections represent the carbon atoms. And on these carbon atoms, H and OH groups are bonded like this. On the third carbon atom, remember it. This is first one, this is second and third. OH is on the left hand side, and for fourth, OH is on right hand side, and fifth again OH is on right hand side. Okay, and this is also CH2OH. This is the open chain structure. Now this OH of this fifth carbon atom, okay, this fifth carbon atom, this is linked with this carbon. Okay, see this one. This H from this fifth carbon atom will join to this oxygen, making OH. Okay, and this oxygen will link this carbon, that is carbon of aldehyde group, and this is fifth carbon, and this is represented like this. Okay, this first carbon atom and this is the fifth carbon atom, and this oxygen is making bond with these two carbon atoms, and on the first carbon atom this OH is on right hand side. Okay, and that's why this is called alpha D plus glucose. Okay, and if OH is on the left hand side at the first carbon atom, then this is called beta D plus glucose. Clear? I think you are able to write these cyclic structure for alpha D plus glucose, and this is for beta D plus glucose. Okay. Anomers. The two cyclic hemiacetal forms of glucose, that is alpha and beta, differ only in the configuration of the hydroxyl group at C1 called anomeric carbon. Such isomers, that is alpha form and beta form, are called anomers. Okay. Alpha form, that is alpha glucose, have OH on right side on anomeric carbon, while beta glucose have OH on left side on anomeric carbon. Okay. Next one is pyranose structure. We have discussed the cyclic structure of glucose, and there are the 6 members, 6 atoms in this cyclic structure. The 6-membered cyclic structure of glucose is called pyranose structure in alpha and beta in both the case, in analogy with pyrene. Okay. Now let us see. This is the structure of pyrene. Okay, and in this form we can represent alpha D plus glucose and beta D plus glucose, and these representations are known as alpha D plus glucopyranose and beta D plus glucopyranose. Okay, now just try to understand. We can arrange again. These are the 6 carbon atoms. Okay, now we will write the cyclic structure. And this is first carbon atom, then this one is second, this one is third, this one is fourth, and this one is fifth, and this one is sixth. Okay, now this first carbon atom and fifth carbon atom link with the oxygen. Okay. Now, in case of alpha glucose, OH is on right side, like this. Okay, and second carbon atom, again OH is on right side, but on the third carbon atom, OH is on left hand side. On the fourth carbon atom, OH is on right hand side. And in the fifth carbon atom, this H, okay, and this one is the sixth carbon atom. Now this we will convert into this pyrene structure. Okay, so just try to understand. You can draw like this. This is a 6-membered ring. Okay, first carbon atom. Now just try to these. That is the groups which are attached on the left hand side. Draw a top of this like this H, and OH is like this. Okay, on the second carbon atom, this is H, which is on left hand side, right on above, and this is OH. On the third carbon atom, OH is on left hand side, that's why this is on above, and this is H. And on the fourth carbon atom, you can write this is H, and this is OH. And on the fifth carbon atom, this H and CH2OH is there, and write this CH2OH on the ring, above the ring. Okay, and this H is this. We can say this is first carbon, this is second, this is third, this is fourth, this is fifth, and this one is sixth. This is alpha D plus glucopyranose. Okay. Now, if in case of beta, what is the change? There is change on the first carbon atom. Okay. On the first carbon atom, OH is like this. Okay. This OH will be on the left hand side. That's why left hand side will be written above. OH, then this is H. On the second carbon atom, this is H, this is OH. On the third carbon atom, this is OH, this is H. On the fourth carbon atom, this is H, and this is OH. And on the fifth carbon atom, this CH2OH is written here, and this H is written here. Okay, this is your alpha D plus glucopyranose, and this is beta D plus glucopyranose. Try to make these structures. Generally, there is one question in the board exam. Write the pyranose structure of alpha D or beta D glucopyranose. Okay, you must be able to write these structures. Thank you.